Hi, and welcome to our third lesson in our probability chapter. Today we're going to be talking about the addition rule, which you will have heard before, and disjoint events, which you may not have heard by that name, but I think you are familiar with too. I'd like to ask you a question. Do you like chocolate chip or sugar cookies? Another way to ask that question, do you like chocolate chip or sugar cookies? In other words, the first question sort of was saying, do you like one or do you like the other? The second way I asked that question was meant to sound like, do you like either one or both, right? The word or can take on different meanings to different people. However, in statistics, it always means, do you like one or the other or both, right? One or the other or both. So today we want to talk about probability situations where we're asking to have one or the other outcome, or maybe both. Right? Two events are said to be disjoint. This is the word we said we were going to introduce you to. Two events are said to be disjoint, or another way of saying that is mutually exclusive. Two events are disjoint or mutually exclusive if they both can't happen at the same time. Again, two things are said to be mutually exclusive or disjoint if they both can't happen at the same time. So if you go back to the cookie question, those are not disjoint, folks, because people can like both chocolate chip and sugar cookies. So not disjoint up there. I'd like to ask you to test your knowledge of disjoint by looking at these examples. Are the events roll a 6 and roll a 3 disjoint? And I believe that you would have to say yes to this. One roll cannot be both a 6 and a 3 at the same time. These are disjoint. So the probability that you roll a 6 or roll a 3, there are a couple of ways that you could think about that, but I think the easiest one is those are 2 out of 6 possible outcomes when you roll a die. So that's a 1 in 3 chance when you reduce that you could roll a 6 or roll a 3. Okay, what about this? The events roll a 6 and roll an even number. Are those disjoint? You would have to ask yourself, can they both happen on the same roll? And the answer here would be not disjoint, because they can both happen on the same roll. Okay? Not disjoint because they both can happen on the same roll. So the probability that you roll a 6 or roll an even has to be figured a little bit differently. If up here we said roll a 6 can happen 1/6 of the time, roll a 3 can happen 1/6 of the time. Essentially, we added, folks. We said that, yep, this can happen or this can happen, so we added. If you come down here and think about that, roll a 6, well, that can happen 1/6 of the time. Roll an even number, well, that happens 3/6 of the time, right? That's half of the choices. However, if you think about that, we've counted one of these outcomes twice. We counted roll a 6 here. It also happens here because 6 is one of the even numbers. So we end up having to subtract 1/6 because it got counted twice. That 6 got counted here and here. So the probability for this happening would be 1 plus 3, which is 4. 4 minus 1, 3/6 of the time you could roll a 6 or an even number. That's a little bit weird, but it's not anything that we've not heard before, right? The word or in probability always means add. Okay, today we're going to be talking about whether or not you have to just add if outcomes are disjoint, or if you have to add and subtract, that is if they are not. So the data at the bottom of the page comes from a poll that I took in a class last year. Kinda. I sort of made it up. However, I've done it before and the results were close to this. So I asked these questions. First of all, is vanilla your favorite ice cream flavor or chocolate? And I only gave those two choices. In this class, 13 people said that vanilla was their favorite, so 13 of these. And the other 12 said that of the two choices, chocolate was favorite. Let me ask you this question. Are those things, are those outcomes, vanilla favorite or chocolate favorite, are those disjoint or not disjoint? You would have to ask yourself the question, can one person be both? And in this situation, they can't be. That makes them disjoint. One person can't have two favorite ice creams, not allowed. The same people, 13, who said that vanilla was their favorite, and then I asked again, are you taller than 5'4"? In this case, as you can see, 20 of the 25 people were 5'4" or taller. Okay? Now, let me ask you this. Are those two characteristics, having vanilla as the favorite ice cream and being taller than 5'4", are they disjoint or not disjoint? You ask yourself, can one person be both? And the answer is yes, they can. Those are not disjoint because one person can have both characteristics. Now, keeping that in mind, I'd like us to use this table to answer some probability questions. So I'm going to ask you to think about this. Can you find for me the probability that if a person is selected at random from this class, they are shorter than 5'4", or like chocolate? Now, as you look at the table, we can see both of those possibilities. You ask yourself, are these disjoint or not? Okay? If they're not disjoint, it makes a difference, because if we have overlap, we have to worry about that. The probability that someone in this class was a short person, I know that's not a nice way to say it, was 5 out of 25. The probability that someone liked chocolate ice cream as their favorite was 12 of 25. You must ask yourself, if these are not disjoint, have we counted some people twice? So the probability that we are short is here. The probability that we like chocolate is here, and you can see that we have counted 3 of those people twice. That's not good. You only get to get counted once in this poll. So the probability that someone is either shorter than 5'4" or chose chocolate would be 5/25 plus 12/25, that's 17, minus 3, or 14/25. Very good. Okay, now ask yourself, what's the probability that someone was taller than 5'4" or not taller than 5'4"? Well, that seems pretty easy to answer. That should cover our whole class, right? Because these things are disjoint. You can't be in both categories. So we should, when we look at these probabilities, add up to everyone. The probability that someone is taller is 20/25. The probability that someone is shorter, 5/25. Since those are disjoint, we just add there, and we get 25/25, which is, as you would expect, 1. We accounted for everyone. Let's see if we can't recap that in a more formal way. Okay? A property of disjoint or mutually exclusive events is that no person can be both. So the probability that you get both A and B is equal to 0. It cannot happen. Cannot happen. So, to wrap up what we've said, symbolically, the addition rule for mutually exclusive events says if two things are mutually exclusive and you want the probability that one or the other of them happened, you take the probability of the first and add to it the probability of the second. We did that, folks, for our folks who were shorter than 5'4" or taller than, okay? For non-disjoint events, that is for things that are not mutually exclusive, where one outcome can be both, you must account for the overlap. So the probability that you get A or B becomes the probability that A happens plus the probability that B happens minus the probability that both happen. Okay, that's the formal way of showing that. We have one more problem, one more example to look at, and the numbers are big here, but we're not going to let that bother us. Of the 34,071,000 people in the U.S. who fish, 1,847,000 fish in the Great Lakes, 27,913,000 fish in other freshwater, and 9,051,000 fish in saltwater. Folks, if you add these values, you'll see that this adds up to more than 34,071,000 people. So we have some overlap there. As you're categorizing the people who fish, are these categories fish in the Great Lakes, fish in other freshwater, and fish in saltwater disjoint? And the question would have to be no. Okay, they're not disjoint because there has to be overlap if these add up to more than 34 million. Are they complete? And I think you could say yes here, because when you get fresh and salt, you've got complete categories. So yes, we've accounted for everything, but no, they're not all separate, because of course the Great Lakes are also other fresh water. So suppose it says we randomly select a person from among those who fish. Can you find the probability that they fish in salt water? And I believe that you can. The probability that you fish in salt water, well, it tells us that 9,051,000 of the 34,071,000 fish in salt. Can you find the probability that someone fishes in freshwater? Well, you might be concerned about that because we know that there's some overlap, but folks, you definitely can, because it would be the same thing as 1 minus the probability that you fish in salt, right? Because you either fish in salt or fresh, right? These people who fish in the Great Lakes, they could fish here, and we know they fish here, so there could be overlap, but we can definitely find the probability for fishing in fresh if we consider 1 minus that probability. And I'm going to leave it at that. You can find that number if you so desire. So that's the end of today's lesson. I hope you'll get out there and try that. You try as quickly as you can.